This video is to cover linear equations. Alright, linear equations is of the form ax plus b equals 0, where x represents your variable. The degree of all linear equations is first order. The way you identify the degree is looking at the exponent of the variable. So we have our linear equation. Our variable is x. When you don't see a number attached to the upper right hand portion of your variable, it's understood that that degree is 1. So linear equations has first order as their degree. Alright. The goal of linear equations is to get the variable by itself. Alright, so let's say we have our linear equation in its generic form. The goal is to get the variable x by itself. So there's several things that you can do, but you want to make sure you do it on both sides of the equal sign every time to maintain equality. So the first thing we're going to do is subtract b from each side. So now we have ax equal the opposite of b. Now, is that b by itself? I'm sorry, it's x by itself. If x isn't by itself, you have not yet completed the problem. Now, the next thing we're going to do is undo this multiplication. We undo multiplication by dividing. And that leaves us with x equal opposite of b over a. And we have just gotten the variable by itself. Therefore, we've solved this linear equation. All right, let's go ahead and do a legit example. We have 4x minus 7 equals 13. All right, we know this is a linear equation because the variable with the highest power in there is 1. And our goal is get the variable by itself. So we want to have variable equal to constant terms. Variable equal constant. Just have that in your mind the entire time. Variable equal constant. And constants are any real numbers. Those are constants. All right. So the first thing that we're going to do is we'll add 7 to each side. So we have 4x equal to 20. Does the variable equal constant? The variable isn't solo, so we need to undo what we have present. Now the variable equals a constant. We have reached the final stage. The solution for that equation is x equals 5. All right. Let's pick it up a little notch. Okay. Now, there are several ways to solve this problem. Don't let the fractions or anything throw you. All right. Because we're just going to work it. We're not afraid of fractions. A lot of people, oh, it has fractions. Oh, no. No, we're not afraid of fractions. We're going to identify some little techniques to help us take care of these fractions. All right. So I'm just going to change the color of this denominator right quick. And I'm going to change the color of this other denominator. And, oh, it won't. Okay. All right, so we have 3 and 4 as denominators. All right, so what I'm going to do is I'm going to multiply every single term by the product of those denominators. So the first term here, multiply it by 3 times 4. I'm going to multiply this second term here by 3 times 4. And I'm going to multiply this final term over here by 3 times 4. The reason why I'm doing this is so that we can get that denominator that we all like, the denominator of 1. All right, and we multiplied everything by the exact same thing, so we didn't change anything. So what we're going to go ahead and do is, if you look now, we have a 3 in the numerator and a 3 in the denominator. 3 divided by 3 is 1. So we have 1 times 4 times 1. This first piece leaves us with 4x minus 1. When we go to the next term, we have negative 3 times 4. That gives us negative 36. And then when we go to the final term, we have a 4 in the denominator and a 4 in the numerator. 4 divided by 4 is 1. That leaves us with 3 times 3x plus 2. I know it looked like it was going to be scary by adding in those products, but it actually simplified things for you a little bit. Next, you want to distribute. All right, so the next phase is to distribute. So we have 4x minus 4 minus 36 equals 9x plus 6. Simplify. 4x minus 40 equals 9x plus 6. Move the variables all on one side and the constants on the other. I like for my variables to be on the left, so I'm going to bring this 9x over. It's positive, so I undo a positive by subtracting. And that leaves me with negative 5x minus 40 equals 6. Next, I'm going to move this constant over. I undo subtraction by adding. And that leaves me with negative 5x equals positive 46. Finally, I'm going to get the variable by itself. Variable equal to constant. Solution is x equal negative 46 fifths. Okay. All right. Don't let this right here throw you any kind of way. You treat it the exact same way. I'm just going to take this little piece right here. Since it's positive, I'm going to subtract it to the other side. And I'm not going to give myself a headache. I'm going to toss this into a calculator. We have 23.03 minus 4 divided by 12.231. All right. And then I have to get this variable by itself. So I'm going to divide all of that by 3.81 so I can get my variable by itself. And this is a good opportunity for some calculator example, bringing in the app that can represent a TI 83 or 84. All right, so we're going to bring in that app. And we're going to clear this out. We have 23.03. 23.03. Well, let's put it in parentheses. 23.03 minus 4 divided by 12.231. 4 divided by 12.231. I made a mistake, so I'm going to hit the delete sign, go back and then hit the delete sign, put the 0.231, close my parenthesis. That takes care of everything in the numerator divided by. Now I'm dividing by 3.81. And that gives me 5.9588. X is approximately 5.9588. But let's make sure we read instructions. The instructions say round to 2 decimal places. So X is approximately 5.96. Okay. Solve problems that lead to linear equations. Now, when you're solving problems that lead to linear equations, it doesn't necessarily start out as a linear equation. So the first thing we're going to do is make this thing appear as a linear equation. I'm going to go ahead and start by distributing on each side of that equal sign because we have some distributions that can take place. All right, I have 3x times everything in that second group of parentheses. So I'm just going to write this all out. 3x times x plus 2 because I want to make sure I get everything. And then I have -1 times everything in that second group of parentheses. So I have everything, every product set up for the left side. I'm going to go ahead and do the same thing for the right side. I have x times everything in the second group of parentheses. And then I have +3 times everything in the second group of parentheses. Okay. That's my first distribution. Second distribution, distribute everything through. So we have 3x squared plus 6x minus x minus 2 equals 3x squared minus 2x plus 9x minus 6. Combine like terms and simplify. We have 3x squared plus 5x minus 2 equal 3x squared plus 7x minus 6. Get your variables all on one side. We're going to start off with the ones with the highest power. Well, if we subtract 3x squared from each side, that goes to 0. That's 0, and that's 0. So that leaves us with 5x minus 2 on the left and 7x minus 6 on the right. Again, I like for all my variables to be on the left. So I'm going to move my variable, and I have -2x minus 2 equal to -6. Move my constant term to the right-hand side, and that gives me -2x equal -4. Solving, we have x equal to +2. Okay. Now, remember the trick we did with the denominators. We're going to still use that trick even though these denominators look weird. But first of all, I need to introduce a little information. And that information is when you have a variable in the denominator, if variable is in the denominator, and I'm going to just write D for denominator. Denominator cannot equal 0 is your first step. Set the denominator not equal to 0, and then find out what your solutions cannot be. So we have x minus 1 cannot equal 0. If we solve this little component, we have x cannot equal +1. X plus 3 cannot equal 0. If we solve that, we have x cannot equal -3. All right. Now, what we're going to do, now that we know what cannot be answers, we're going to find out what are the potential answers. And we're going to use our little denominator trick. All right, so looking right here, x plus 3x minus 1. That contains everything. So we're going to just go ahead and multiply every term by x plus 3 times x minus 1. So the first term times that. And then this second term right here times x plus 3 times x minus 1. And then finally the last term. Oh, that doesn't look good. The last term, x plus 3 times x minus 1. All right. X minus 1 in the numerator, x minus 1 in the denominator. Divide each other. That gives you a positive 1. So that leaves us with x plus 3 times 2 equals. Go to your next term, you have a x plus 3 in the denominator, x plus 3 in your numerator. Divide those, you have 3 times x minus 1 plus 1. All right, so now that we've simplified that, we distribute and go through the distribution. We have 2x plus 6 equal to 3x minus 3 plus 1. Combine like terms and simplify. We have 2x plus 6 equal 3x minus 2. I'm going to move my constants to the right. So we have 2x equal 3x minus 8. I'm going to move my variable to the left. So we have negative x equal negative 8. Divide each side by negative 1. X equals positive 8. Now, you check that answer that you got. It's not one of those initial cannot equal, so that is solution for that equation. All right, rounding it on up, we have again, you have variable in the denominator, so the denominator cannot equal 0. So x minus 2 cannot equal 0. When we solve this, we get x cannot equal positive 2. And all we did was add 2 to each side. And we're going to take each one of those terms and multiply it by that denominator. So we have x minus 2 in the numerator, x minus 2 in the denominator. That's 1 times 3x. Leaves us with 3x. Plus 1 times x minus 2 equals x minus 2 divided by x minus 2. That is 1 times 6. Leaves us with 6. So we have 3x plus x minus 2 equals 6. So that gives us 4x minus 2 equals 6. 4x equals 8 when we add 2 to each side. Divide each side by 4. And x equals positive 2. But look, at the very beginning, we said x cannot equal positive 2. But the only solution that we came up with is x equal positive 2. So you cannot equal and not equal at the same time. So you would say there is no solution. All right. Then you might want to invest some money. So you have to read through your word problem. This is real life activation right here. All right, so you have a total of $16,000. Total of $16,000 invested. Some in stocks, some in bonds. So we're going to some variables right here. I'm going to write a P for stocks and a B for bonds. If the amount invested in bonds is 1/4 that invested in stocks, how much is invested in each category? All right, it said bonds is equal to 1/4 of stocks. All right, and we know that all of the money is invested in stocks and bonds. All of the money is invested in stocks and bonds. In this total layout, we have two variables. What we're going to do is substitute in one of these variables. But here's a little trick. I want to get rid of this fraction over here, so I'm just going to multiply each side by 4. So I have 4b equals p. So p is equal 4 times bonds. And I'm going to substitute. So we have 16,000 is equal to 4b plus b, because p represents 4b. And 16,000 is equal to 5b when you add those together. And when you solve for b, you have $3,200 that goes into bonds. If 3,200 goes into bonds, how many go into stocks? Well, stocks is equal to 4 times b, so we would say stocks is equal to 4 times b. So that would give us $12,800 is equal to stocks. Or you could have subtracted that 3,200 from 16,000, because that would have left remaining. When you add those two together, they better add together to be $16,000. All right. And our final example. All right, so we want to find out how much money this person makes an hour. It says Andy grows $440 1 week by working 50 hours. His employer pays time and a half for all hours worked in excess of 40. All right, what is Andy's hourly wage? All right, so in excess of 40. If he worked 50 hours, how many hours were in excess of 40? Meaning how many more hours than 40 to get to 50? All right, so that's 10 additional hours. So he got $440 that he made. He get his money, his total money, by the hours that he worked. So he worked 40 hours at his regular pay, plus 10 hours at his regular pay, plus half of his regular pay. All right, so when we go through and simplify all this, we have 40x plus 10x plus 5x, and we have $440 equals 55x. So that lets us know that Andy is really working hard out there at $8 an hour. All right, I hope this video helps you, and I will see you